In this section, we're going to be solving radical equations, and the first thing that you need to do is isolate your radical. So I'm going to move the 4 to the other side of the equation, and then I have the square root of 3x plus 1 is equal to 4. And now that our radical is isolated, we're going to go ahead and square root both sides of this equation. And the reason that we are doing that is to remove our radical symbol. So I'm squaring both sides, and then on the left side, the exponent of 2 is going to remove off that radical symbol for us, and only the 3x plus 1 is going to drop down. And then 4 squared is 16. And then from here, all you need to do is subtract 1 and then divide by 3. And x is equal to 5. Now you need to check your answers when you are solving a radical equation. And so I'm going to go ahead and take the 5 that I got and substitute it back into my original equation. So in for the x goes a 5, and then we'll go ahead and calculate out the answer here. 3 times 5 is 15. 15 plus 1 is 16. And then the square root of 16 is 4. And that makes a true statement, true equation, and that answer works. Okay, so let's go ahead and do example 2 right away. First thing you need to do to solve this radical equation is you need to isolate your radical. So I'm going to go ahead and subtract 4 off of both sides of my equation. Then I end up with the cubed root of 5x minus 7 is equal to 3. And to remove my cubed root symbol, I'm going to go ahead and cube both sides. And the cubing this side is going to remove my cube root symbol, and the 5x minus 7 is going to drop down all by itself, and on the right side we get 27. And then I'm going to add 7, and I get 5x is equal to 34, and then I'm going to go ahead and divide both sides by 5, and then that is our answer. And let's go ahead and do our check. We have the cubed root of 5 times 34 over 5 minus 7 plus 4 equals 7. Okay, then we get the cubed root of 34 minus 7 plus 4 is equal to 7. And then we have the cubed root of 27 plus 4 is equal to 7. And the cubed root of 27 is 3. And then that makes a true equation, 7 equals 7, and that's true. So that's a solution, and it works. All right, let's go ahead and do example 3. The first thing that you need to do is you need to isolate your radical. So I'm going to move the 2 to the other side of the equation to start. And then I still have a 2 out front, and I need to remove that 2. So I'm going to go ahead and divide the left side of my equation by 2, which will cancel out that 2 in front of the radical symbol. And then what you do to one side, you're going to do to the other. So I divide my right side by 2 as well. I'm going to end up with the fourth root of x plus 11 is equal to negative 1. And then to remove my fourth root symbol, I am going to raise both sides of this equation to the fourth power. So raise the left side to the fourth and raise the right side to the fourth. On the left side, the raising the fourth root to the fourth power is going to remove that root symbol, and the x plus 11 is going to be the only thing left. And on the right side, we have negative 1 times negative 1 times negative 1 times negative 1, which turns out to be positive 1. And then we're going to go ahead and subtract 11. And then you get x is equal to negative 10. And let's go ahead and check our answer. We have 2 times the fourth root of negative 10 plus 11, and then plus 2 equals 0. And then we get the fourth root of positive 1 plus 2 equals 0. And the fourth root of 1 is just 1. And then you end up with 2 plus 2, which is 4. And 4 does not equal 0. And that makes a false equation or false statement. And therefore, this is not a solution, and it is extraneous. It's an extraneous solution. Okay, let's go ahead and do example 4. In example 4, you have to isolate your radical. So I'm going to go ahead and move the 5 to the other side. And then I end up with the square root of x plus 7 is equal to x minus 5. The x and the 5 aren't like terms, so you're just going to go ahead and write those side by side. And then I'm going to remove my radical symbol. Now that my radical has been isolated, I'm going to remove that radical symbol by squaring the left side, and then what you do to one side, you're going to go ahead and do to the other. On the left side, the x plus 7 is going to drop down all by itself. Squaring the square root symbol is going to remove it. And on the right side, you actually have to expand out x minus 5 squared and FOIL. So we have x plus 7 is equal to x squared minus 5x, and then my inner terms will be another 5x, so altogether we have minus 10x, and then plus 25. And then I notice that I have a quadratic equation with all three terms. I have an x squared, an x, and a constant. So I'm going to go ahead and move everything to one side of my equation and see if it's going to factor for me. So we get 0 is equal to x squared minus 11x plus 18. And then we are going to find factors of 18 that add to negative 11. Negative 9 times negative 2, multiply to positive 18, but add to negative 11. And then you get x is equal to 9, and x is equal to 2. And then we're going to go ahead and check our answers. So we have 5 plus the square root of 2 plus 7 equals 2. So in this problem, I substituted back in the 2's. You get 5 plus the square root of 9 is equal to 2. And 5 plus 3 equal 2. That is false. So that is an extraneous solution. And then I'm also going to go ahead and check my 9. So we have the square root of 9 plus 7 is equal to 9. So I put 9's in for the x's, and then we get 5 plus root 16 is equal to 9. And then we have 5 plus 4 equal 9. 9 equal 9 is definitely true. And so that is a solution. The 2 is extraneous, and the 9 works. So 9 is a solution.